Hi, welcome to this channel. So I do often get queries related to kernel build and kernel compile and customization. So one among the questions is about the options you provide in make menu config. The options like star and M, and without, if you don't enable anything, of course we are not enabling that module. But other than that, I do get queries related to this selecting something as an M versus star and something like a sub module. What are its implications? So it is quite simple. As you imagine, let's assume this stack of Legos are your built compiled kernel, which contains many modules. Okay, it can be any subsystems and modules. So let's assume you need a specific device driver or some kernel module. See, the confusion often lingers among developers is whenever they try to venture in kernel development, they often see some bad examples. They assume anything as a kernel module is some kind of device driver or something. It's just not that case. A module can do anything. The module can create any virtual drivers. It can provide a support for a physical device as a device driver, or else it can have some functionality of a kernel also. So it can be anything. So let's assume you have some couple of kernel modules. So one thing you can do is you can statically build these modules and make it a part of Linux kernel itself. So if you do something like that, it let's represent these tiny bits of this Lego bricks as those additional modules. So you can put inside, and then you can build your kernel with everything in place. So your built kernel will be so and so, and because you have now additional modules, it is little bloated up. Let's imagine a scenario not like this: 2 modules, you have hundreds of additional modules. You are enabling entire networking subsystem, you are disabling entire networking subsystem. So it is going to change drastically the amount of modules it adds. So if you do such a thing, it has to enable some network drivers. Apart from that, it has to also enable the entire networking subsystem. That includes IPv4 stack and various other things. Okay, so hundreds of modules or even thousands of modules will get added just by enabling something and disabling something. So this is what happens. So if you build this way, and if you build it is statically added in the kernel binary, the moment you boot your kernel binary, it is going to have these features. Okay, so this way you can do. And let's suppose these 2 added bits are some NICard device drivers, or some GPU video device drivers, or some sound card device drivers. So let's assume that way. So in that way, what you can do is you can build the kernel and enable the option as M, and that time when you plug that device or something, let's assume it is hot pluggable device. It is possible with some USB devices, as we know, and if not USB, if it is some PCIe connected device, then it is not hard pluggable. Okay, the moment you boot, the kernel knows, and the kernel is going to do this. It is going to add these modules within the same. So in a way, it is going to be added into the kernel after it is booted. So this way, these modules will get plugged to the kernel, and it will get overall the runtime footprint will increase. So as you add more modules in the runtime, anyway it is going to not make any changes. It is just getting added in the runtime, versus earlier approach, it is built in the boot time. So it is going to add like this, and now your running kernel have these additional 3 modules, or let us be 300 modules, whatever, added in the runtime. So these are the ones whenever you provide this. Let me open another window. As you can see, I just done some kernel build. I'm not sure whether it is successful or not. I'm just doing something in the back end so that I can show a demo. Okay, if you do this ls mod, it is going to show all these modules which are loaded. You can see there are like around 50-60 modules or more than that, and some are like dependent modules, and it shows this hierarchy of whatever is loaded. So you have these things, but to be frank, it is nowhere with respect to the real amount of modules which went inside this loaded kernel. The reason is they have been compiled with that star option or the asterisk, so it is a part of the kernel. Statically it's a part of the kernel, so the moment it boots, it is going to add all these modules in the picture, so it is not something added in a dynamic way. So which is why ls mod, it is not going to list, but it is going to provide the support of that particular device. That way, if you see, if I do ls PCI or something like that, and if I do grep ethernet, I can see my NIC card, and I can also correspond my NIC card module ls mod, and if I do grep grep 1000 or something, this is my NIC card E1000E. This is an Intel NIC card device driver. So since its kernel is supported or compiled with this module enabled, I'm not saying it is statically linked, it's just module is enabled, so it has compiled that specific module. So I have this particular NIC card support, you can see there. So now the question arises, dynamically linking or statically linking. As you know, anything if you do ls mod, you can remove these modules. I mean, you can deactivate and remove these modules, which means it is going to be removed, something like this dynamically. Okay, so I can anyway do that rm mod and E1000E, and I can do this sudo, and it is going to challenge me the password, and the moment I do, it is going to chop off my internet connectivity because it's the main NIC card driver. So having said, still I can do the same, and if I do ls mod and grep E1000, it is vanished. And if I need this module, it is in a strange way I can enable this module even without any kernel build. I'm saying, let's assume you have a version Ubuntu desktop installed in a laptop or a PC, and you do this, it is going to work something like this. Again, you cannot do this E1000E. Again, you need to check what is the NIC card driver which you are using or inbuilt in your laptop or a PC, and it is linked towards this. And this NIC card is an inbuilt NIC card of my gigabyte motherboard, and it's an inbuilt Intel NIC card. So this is what. So what I can do is I can also do one more thing. I can do ls, I can do uname -r and check the kernel version. You can see it is 5.0 kernel. It is what comes with this Discodingo, and currently it is the subversion is 14. So what I can do is I can go to lib modules, and for getting these KO files or the compiled kernel objects or kernel modules, you don't need to build or something. It will be already copied in your system. So most probably you will find them inside this folder 5.0.0 14 generic. You can see there is the old one which is 13 generic. So recently I did a system upgrade, so I have two kernels. One is the old one which is the version 13, and the new one which is the version 14. So I can go inside, and if I go inside, it is going to show all this hierarchy. You can go somewhere inside kernel, and you can go to drivers, and you can go to net, and you can go to ethernet, and you can go to Intel, and you can find E1000E folder over there. So let me highlight the same, since it is lacking this contrast. You can see here E1000E, and this is that E1000, and this is a i40E, which is Intel's 40 gig NIC card kernel driver, and stuff like that. And this is the old Intel 100 Mbps NIC card driver. So I can go to E1000E, and if I do that, you can see this is the kernel module. And please note, this is nowhere I have compiled or touched the system. It's a pristine Ubuntu kernel. So I can do this, either do this way, mod probe E1000E, or I can do this in an explicit way, sudo insmod E1000E KO, and it is going to accept, just like that. And I have not compiled anything in the system, nor I have downloaded the sources or anything of 5.0 version 14 kernel, Ubuntu's kernel. So it just works this way. So this is what is the thing, advantage you get with, M option in make menu config. So that way, to demonstrate, you can see here I have a very old kernel. I'm doing some work on this 4.4.1 kernel. So if I do this make menu config, you can get those options. So let's go to that relevant driver section so that we can understand in parallel what I have done there versus something like this. So you can go here, you can see here in the device drivers, you can go to Ethernet. So come down, you should find somewhere Ethernet drivers, somewhere here. Ethernet, I think I missed out somewhere here. I think I need to go inside drivers. I think inside network device support, I'm sorry. So inside that you should find, of course. So network device support, and inside that you should find somewhere this Ethernet. Please note, you can see here it also contains many other device drivers scattered around without getting categorized and stuff. Okay, so we just ignore that hierarchy, whatever they provided. So you can see there Ethernet device driver support, which is under that network device support over here. So under this we have this. So we go here and we can navigate, and we can navigate alphabetically, and you can see here these are the Intel drivers, and you can see Pro Gigabit Express Ethernet support. Most probably this is the one, or else maybe the other one, PCI Express, because of course my motherboard has that PCI Express Intel network NIC card. Okay, so that's what. Of course it is inbuilt, but anyway it is either you plug or else it is inbuilt, it's the same. Okay. To confirm, you can press, you can type H so that it will open up, and it will show the what is the module name, because it is E1000E, not E1000. So E1000 is a different device versus E1000E. So I can press help by clicking H, and you can see it is showing config E1000E. So this is the one which you seen over here of Ubuntu's kernel, which is pre-compiled. And of course when you do Ubuntu install, it is not going to install any kernel sources. It is going to give you the pre-compiled binaries, and it is going to give you also pre-compiled kernel headers and also kernel modules, and which is what you will see when you do dpkg -- list and the filter as Linux, and it is going to show all this, and further you filter as grep 5.0.0 whatever, I'm sorry, extra 0 whatever, and it is going to show all these modules, I mean the packages whatever Ubuntu have installed, which is Linux headers and Linux image, after that modules and modules extra. So each one has a role, and something like headers includes the .h files that will allow you to build any custom kernel modules of a booted Linux system. Okay, you don't need to download the kernel source and then build within that. You can just like that write your kernel modules and build inside the system. So you need Linux headers for that. Other than that, Linux image, of course, that VM image, VM Linux, which is under that boot, it is going to install. Other than that, you can see here Linux modules, and these are the ones which will get installed over into this folder. So pwd, you can see here it will be under that lib modules whatever. So when you install this package, Debian dev package, it will install over there. So this is what. Okay, so if I want, I can anyway remove that old Linux kernel, which is that 5.0.0-14 whatever. So I can not 14, 13 kernel, and I can retain this 14 kernel. But in general, in any Linux system, you will see some past 2-3 kernels, it won't remove them, and it is going to slowly remove the most obsolete kernels. The reason is, if something happens and this new kernel is not booting and the system is not stable, or some device driver is broken and it is not supported, you can revert back to that old kernel and boot always your system. Although grub doesn't show you this thing, you can anyway adjust it timeout, and then you can go back and boot it from that old kernel. So it's always good to have at least 2 to 3 previous kernels, because in case if this recent kernel is unstable, it is making the system unstable, you can anyway boot your old your PC or laptop with your server with that older kernels. Okay, so this is the intent. So as you can see here, you go back, you can see here by default it will be selected as M, and this is the setting, it will be set in config. Before we change here, if you go and open the .config file, you can see here filter as E1000E. I think I need to give in caps E1000E. Yeah, you can see here it is selected as M. Okay, this is what happens if you select here as M, and you will get a KO file. And if you select this as with clicking space, you can see here, by typing space, you can see it shows as star. And if you do this, it is going to set as Y instead of M. Okay, so we do the same, and what we do is I set it as a star, and that alone is changed and nothing else is changed. So let me come out, and once you come out, you can see it asks for confirmation. Let us save that, and what we do is here the config file is open, and let me just come out of that config file from the VI, and let me open once again, and let me search that E1000E, and you can see now it is changed as Y. Okay, so you can see here the rest been set as M, and versus this is changed as Y. And hope you noticed before I started this video, or while starting this video, the kernel is compiling, and that way if you go, whatever it is set as M, and we can see, go to the device drivers, net, Ethernet, Intel, and we go inside this E1000E folder, and you can see it should have created that KO file or whatever, if it is successful. But having said, I have seen some error when it is compiling. I believe it is causing some kind of an issue. Okay, so let us do star.ko. Yeah, it is compiled. Anyway, this part is over, so it has compiled as KO because it is set as M. So what we do is, in the another window, you can see the same path it is. I'm inside the same kernel. What we can do is, we can quickly do a make -j 6 threads or something, and we can do a comparison. Earlier with that option, it has created this KO file. So it's a kernel object or kernel module, but it's a dynamic pluggable kernel module, versus this time when you do that, the KO should vanish technically. Okay, so we wait and see. If it is taking long time, I'm going to cut this video feed and going to restore once it is complete. If it is going to do in a short period of time, I'm going to keep it as it is. Okay, let us see. So we see here ls star.ko. So we see that the right moment where it is going to vanish. Okay, so you can see it is still existing, ls star. So let's just track the same. It is of course going to take time, and since my system is having good performance, but still you may have still IO overheads whenever you do any kernel build. And this is one thing I always insist my students: whenever you have a system you devote and dedicate for any Linux kernel builds, always stick with a good resolution, good configuration system, and also make sure sometimes, if possible, even include an SSD, so that it is going to boost your compile cycles, overall compile and test cycles. Okay, so this is what. So it is doing this. As you have noticed, it is of course showing some errors, but it doesn't matter, because it is anyway going to traverse that path, and it is going to finish that. Okay, so let us see. Yeah, you can see here it has done this, because that's the only thing it has been changed, and rest it is not we have touched. Okay, so you can see here it has passed this change, and now we do ls. And technically we should not see that KO file, but I'm not sure. It is still sticking around, because there is again some error in the kernel build, and if that error moves on, most probably it should delete this KO file. Okay, so I'm not sure what is this error is all about. I need to later check, and unsupported relocation type. I have no idea what is this error, so I need to kind of verify. But having said, I have compiled this kernel sometime in the past, and it is still fine. It's just a test setup. I'm doing some investigation, so it is still fine. But I'm saying you, whenever you do select the module, it is going to be a runtime pluggable module, and it is going to reduce your kernel footprint. Okay, it is going to reduce your kernel footprint. The more you have such runtime modules, your kernel is going to be like this the time it boots. And as you plug these hardware, and provided it has a driver support inside the Linux kernel, it is going to add any such kernel modules dynamically on demand, and it is going to plug like this on demand in the order as you use your devices or plug your devices. So it will be added like this, and slowly it will get sort of populated. And then in the runtime, the moment you do ls mod, it is going to show with all this loaded or plugged in kernel modules. And since these are dynamically plugged in, you can remove them. But if you compile with that star option, what happens is you cannot remove them. Okay, so this is what. So I can even do one thing, E1000E. This is something I'm really dead sure about, but having said there is some kind of build issue, let's not get deep. So one thing I can do is I can remove this E1000E. I can remove this E1000E dot ko as well as rm E1000E dot c and stuff. I'm sorry, not c dot o. And what we do is we can try this and also this mod dot o whatever. Okay, so we just remove this as well, and hope this removes all those things. Okay, so we can try once again a quick kernel compile. Okay, so make -j6, and we see that if it passes that step. But just 2 days back I have done, but this is what it happens. So when you select as option M, it's going to be inside that lib modules folder after you do compile and install this stuff. And in case if you don't do the same, it is not going to be in this folder, because now it is a part of the kernel itself. It is already the part of kernel itself, but it is not activated till the time you plug the device. Especially this is true for any such dynamic pluggable devices like this. See, we take a sample like this. See, this is also a NIC card, but this is a USB NIC card. But what happens is the driver is not going to be there. The moment I plug, then it is going to be active. The moment I pull it out, it is going to vanish. So we can really test this stuff also. So what we do is here, okay, here it is compiling. Let it do the same. Yeah, but it has, you can see here, it has passed this folder. Anyway, it has done whatever, and we got that .o file. Again, we do this ls and ls star ls e1000e dot star. You can see here it has anyway once again compiled, although I have deleted. So this is what it is. So anyway, to test this, what we do is we go back to our regular system, and in the drivers somewhere each driver is lingering around, and it is also going to be as a pluggable module, not earlier compiled with the kernel, so and statically built. Okay, so let's not take too serious. I mean, I do understand when some system developers see these things, so they think about the static loading, dynamic loading and stuff. Let's not too much confuse. Let's keep it very simple. Okay, so these are like pluggable kernel modules, so let's not go in depth. So if I take this and plug this, and what I do is before plugging, I can even capture its log messages, tail -f where log kernel log. So what we do is the NIC card is not still connected. What I do is, let me just plug the same, and the moment it is plugged, you can see the kernel driver is coming alive and it is getting loaded, and somewhere you can see the footprint of that device driver name. Hopefully this is the driver name which this USB NIC card is getting used. Okay, so what we do is here we go back and ls mod we do, and do a grep and filter this driver, and you can see here it has been loaded, and along with that it has also loaded some other subsystems. Okay, because it's a USB NIC card, this is not a PCI NIC card, so it has to load some supporting drivers or whatever. So it is loading the same, and then we have the main driver also loaded up, and it is initialized. You can see here it is initialized. I can cancel this, I can do if config, and it is supported here. Since it is not connected with any Ethernet cable, I have this Ethernet cable. Since it is not connected, you can see here, okay, since it is not connected, it is not going to have any IP address or whatever. So what we do is we again track this varlog messages, and let me pull this card out. So the moment it is pulled, you can see it is showing this notification in log messages, okay, and it will be of course coming from that driver before doing that uninit sequence, okay, module exit sequence. So what we do is we again go back here and we do an ls mode. So this confirms whether these modules which are loading dynamically are also getting unloaded dynamically, okay. So when we do this ls mode, it is still active, okay, and it depends on how you configure your driver, because some drivers you can anyway deactivate, and of course you can quit the moment it is not utilized or not put inside. So you can anyway do that, and in this case the driver is still existing as a part of this ls mode, which confirms that the driver is not fully exited. It is still there, but it has deactivated whatever it is. And what I do is I can once again plug, and moreover, see, the way I have removed is I have just done not a graceful removal of the same. I have not deactivated anything. I just pulled that this USB port out. So of course, I mean, it depends on how they are handling in the driver, okay. So let me just put it back, and what we do is we do a comparison between this whatever it has happened, this versus this, okay. So that's what I mean, not this. Let's go up, okay. So this versus this time, because that time even that modules are not loaded. It's the first time ever I have plugged in. So let's put this back and capture this log messages. You can see this time it shows something like this, okay. So it shows something like this, and if I do this ls mode, it is going to be there, okay. It is going to be there, and of course it is supporting. So if I do if config, it is going to be there. So to test once again, to cross check, what we do is I can reboot the system and I can show you. It should not contain this kernel modules. It is only activated and it is only existing the moment I plugged in this for the first time, okay. So that's what. So I can do that as well, and anyway, we are done with this demo, okay. So this is very clear. Unless you enable as a module, it is not going to create any KO files. And hope when you do this make modules or something, only that time you get this KO files created when you do this kernel compile. So till then, of course, the modules will be created at a later stages. And if you put any star or something like that, and it is going to compile those subsystems or drivers, whatever it is, in the main build, okay, because it's a part of the kernel itself, and it's a part of that VM Linux, okay. So it's a part of that VM Linux, okay. So that is what. So if you don't put a star, it is not going to be a part of that. So when you do a regular make, it is not going to compile the same. It is going to skip that. Only in the stage of module compile, it is going to compile all these KO files, okay. So that's what. So what I do is I reboot the system, and what I do is I also unplug this, and what we do is after it is rebooted, we do this ls mode without this ever plugged in, and see that those drivers are existing in that ls mode output, okay. So let me just reboot the system. So we are back. The system is rebooted. As you can see, it is still not plugged in. So what we do is we do this ls command, ls mode, and before that we also capture this log messages. So we do the same. So you can see it is not loaded. Of course, there won't be any driver instance loaded, okay. So you can see here nothing is happening. It is just the same. The moment you first time enable or put this device, and once the driver is initialized, okay, let me put it back, okay. So this is the first time I'm putting this of a freshly booted system. So the moment it is put, and if I do ls mod now, you can see the driver is loaded, and also it is going to show the activity in the logs, the kernel logs. So this is what it is. And how do they unload that driver or whatever, it again depends on the driver. In this case, although I have taken out, it is not unloading completely, it is still existing in the ls mod, or maybe I need to do some graceful shutdown of that NIC card. Maybe that is something I need to check, I'm not sure. Okay, so if config, I can do one thing, sudo if config that port whatever, and I can mention down, so that way it is going to at least deactivate that NIC card. Okay, so it is down, which means it is going to deactivate -a. It is going to still exist, but it is not enabled. Okay, so this is what. So this time if I pull it out, before that let us see the log messages. So yeah, before that what we do is we just pull it out, and we see this time it removes that driver instance completely. Okay, so we do this ls mod and check. Yeah, it is not removing it. So this is how this particular driver is done. And again, it is something which is specific how you architect and do any driver modules and code. Okay, so that's what. So hope you learned something interesting and useful in this video. If you have anything to discuss, as usual, be in touch via mail or post your queries in YouTube comments. Thanks a lot for joining me. Stay tuned. Have a nice day. Bye bye.